All right, this is 5th grade, Module 1, Lesson 14. And in this lesson, we're going to be dividing decimals with a remainder using the place value understanding. And we're going to ultimately, in this lesson, students are going to be using this standard algorithm for dividing decimals, dividing decimals by a whole number. But I'm going to begin with a couple of problems where we really use those dots and the place value technique so that students understand why the standard algorithm makes sense.
So we have this problem, 5 and 241 thousandths divided by 3. And we're going to be using this place value chart to show how to divide, but we're also going to be bouncing back and forth with the standard algorithm to show how this place value thing leads into a deep understanding of the standard algorithm. Now, first thing I want to point out, being a long-time teacher, 25 years, is the vocabulary. Here, you got 5 and 241 thousandths divided by 3. And pretty much all the students could read this question correctly. They might say 5.241 divided by 3, but that's fine. Meanwhile, over here, it is very common for students to incorrectly read this as 3 divided by 5.241. Now, because they just want to call this divided by, you could say divide into, but probably the best way to read this question is 5.241 divided by 3. So parents and teachers, you just got to be aware of students' tendency to say things backwards. And so even though a student may say it wrong, meaning that student may be saying it backwards, it doesn't mean the student had it wrong in her head. It's possible, or his head, it's possible that the student was thinking the right problem but said it the opposite of the way we're supposed to say it. So just be aware of that. It's kind of tricky. So first thing we're going to do is we are going to model the problem, and we're going to do 1, 2, 3, 4, 5, 2 tenths, 4 hundredths, and 1 thousandth. All right, so now that we've modeled what the problem is supposed to look like, now we're going to go back and forth and between the place value and the standard algorithm. Now, because we're dividing by 3, we've got our 3 groups down here. And what we're going to do is we're going to take these dots and we're going to sort them into these 3 groups. Divide by 3 means you're going to take them and divide them evenly as best you can amongst those 3 groups. All right, and because we have 5 and 3 groups, that means each group is going to get 1 dot. So I'm going to put 1 dot, 1 dot, and 1 dot. And that means these 3 have been used. So what does that look like over here in the standard algorithm? We're going to put a 1 above the 5, and that means we've used 3 dots, so that's these 3, and this subtract, and you get 2 left over. That means these 2 are what we have left over. All right, so now what we're going to do is we're going to take these 2 dots and we're going to cash them in for tenths, and each dot counts as 10 tenths. So this dot gives us 10 tenths, and this dot gives us 10 tenths. So I'm going to cross off those dots because we now have, 22 tenths. All right, so what does that look like over here? That means that's the classic bring down this 2, and you now have 22 tenths. And that's what this means right here. So notice how the 22 and the 22 totally match. All right. So now we have 3 groups and 22 tenths. So how many tenths can go into each of these 3 groups? And the answer is 7. So 1 group of 7, 2 groups of 7, and a third and final group of 7. So that tells us, so how am I going to write that over here in the standard algorithm? I'm going to put 7 right here in the tenths. So I need that dot there. So there are 7/10 in each group, and that's these down here. So that's, we need to cross off 21 because we used 21. So I'm going to put 21 right here. So I'm going to cross off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So then we have this extra tenth right here. So I'm going to go over here to the standard algorithm, and when we subtract, I get 1 left over. So 1/10 left over, and that's this 1 right here. Now we can cash that tenth in for 10/100ths. So that's going to look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have 14/100ths. So what is that going to look like over here? I'm going to bring down that 4, and we now have 14/100ths. And now we need to take these 14/100ths and sort them equally into 3 groups. All right. Well, that means each group is going to have 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that means over here I can put a 4 here. Now how many did we use? Oh, we used 12. So that means I'm going to put a 12 right here. And when we subtract, we're going to get 2. Well, what does that 2 mean? Well, over here we took these 14/100ths and we sorted them, and we had 2 left over. Let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then we had these 2 left over. And so that's this 2 right here. So now we're going to take these 2 and we're going to cash them in for 20/1000ths. And with the amazing power of video, there's my 20 right there. So these got cashed in over here. And so they're now gone. Oh, and that one's gone, by the way. Okay, so now we have 21/1000ths. And so where did that come from in the standard algorithm? Well, this 1 comes down, and that gives us 21/1000ths. And these 21/1000ths can be divided into these 3 groups nice and neat. Each group is going to get 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we're going to put that up here. And that means we used up 21, and we have nothing left over, because when we put 7 in each group, we are going to end up using all 21 of these dots, all 21/1000ths, and we have nothing left over. So that's the connection between the place value chart and the standard algorithm. So this one, I'm not going to entirely solve it. I'm just going to set it up for you. We begin with 5 1s, 3 10ths, 7 100ths. And notice I'm doing it in 5 groups. And then, or sometimes we call it base 10 frames. And then 2/1000ths. All right, so there's my setup. And I like to draw a double line to separate it. I don't know why I do that. And then because we're dividing by 4, that means I need 4 groups down here. So I'm going to draw my 4 groups. And there I have set up the problem. And now what you're going to do is you're just going to begin that process of sorting your dots into 4 groups. And when you have a leftover, you cash it in for the 10 in the column to the right. And you connect it with that standard algorithm. So here we're supposed to be using that standard algorithm, so we're going to begin by writing the problem correctly. And that's the part where I told you sometimes students will take the problem that's given and write it in the same order, but no. This first number goes inside the house, for lack of a better term. I don't know the real word. And then the 6 goes outside the house. So now we're going to do the standard algorithm, but I'm going to try and refer to that place value system. And so what we've got is we've got 110, and that 110 cannot be cut into 6 groups equally, so that turns into 16. Oh, so I'm going to put a 0. That means that 110 cannot be cut into 6 groups, so that's the 0. So now we have 16 ones, and those 16 ones can be sorted into 6 groups. In fact, 2 dots would go into each of those 6 groups. That means we'd use up 12 dots, and we'd have 4 dots left over. I'm going to put this right here. And these 4 ones combined with the 4 tenths gives us 44 tenths. So I'm going to bring this down. We now have 44 tenths. And then we're going to take those 44 tenths and divide them up into 6 equal groups, as best we can. And we can see that each of those 6 groups are going to get 7 dots. So that means we're going to use up 42 dots, and we're going to have 2 dots left over in the tenths place. So those 2 tenths, we can cash them into the hundredths column, and that gives us 20 hundredths. So now we have 20 hundredths, and we need to cut those into 6 separate groups. So that means there's going to be 3 dots in each group, and we're going to have 2 dots left over. So 2 hundredths left over, and we're going to cash those 2 hundredths left over into the thousands and get 20 thousandths, plus the 4 that were already there. So now we're going to have 24 thousandths, and those 24 thousandths can be cut into 6 groups. Each group will get 4 dots, and that means we have no dots left over, and we are officially done, and the answer is 2.734. So here we've got Mrs. Mayuko, and she paid $40.68 for 3 kilograms of shrimp. And what's the cost of 1 kilogram? So, I showed this problem not because it's a really complicated problem, but because it's a perfect example, parents and teachers, of opportunities to draw a tape diagram. So here I'm going to draw a tape diagram, and because there's 3 kilograms of shrimp, I'm going to cut it up into 3 equal parts, and then that whole entire tape is equal to $40.68. And then the question mark is right here. We want to know what 1 of these kilograms is worth. So this is a perfect example of a division problem. This is what the tape looks like when it suggests division. Generally, you're going to have equal-sized pieces, and one of the pieces is going to have the question mark. So that generally means you need to divide. And the division is going to look like this. Now, teachers, a lot of students are going to correctly write this problem down, but that's generally because their strategy is to say, put the small number outside and put the big number inside. Let's teach our students to be a little bit more sophisticated than that when they are trying to set up the problem. How do you know the 3 goes out there? And you could say, well, because there's supposed to be 3 equal groups. Okay, that's a reasonable explanation. So let's do the math here. 3 goes into 4, so 4 dots, 4 tens can be sorted into 3 groups such that there's 1 in each group. It means you've used up 3 and you have 1 10 left over. You cash it in for 10 ones, and now you have 10 ones, and you want to sort those 10 ones into 3 groups. That means each group is going to get 3 dots. You're going to use up 9 dots, and so you're going to have 1 dot left over. So you're going to cash that in, and I'm going to zoom out a little bit here, and you're going to cash that 1 dot, that whole number, into 10 tenths, and so now you're going to have 16 tenths. So 16 tenths sorted into 3 piles or 3 groups means each group is going to have 5 dots. So that means you've used up 15 dots, and now you have 1 dot left over. So by the way, we're now in the decimals, so I need to put the decimal right there. So now we have 1/10 left over. We're going to cash him in for 10 hundredths, and that means we now are going to have 18 hundredths. And 18 hundredths divided into those 3 groups means we can put 6 dots into each of those 3 groups. And that means we've used up all 18 of our dots. We have nothing left over. And so that means each piece is $13.56. So each kilogram is $13.56. And the last one, I just wanted to choose this one because I'm not going to do the math. I wanted to really show you the tape diagram because it's kind of cool. So it says the total weight of the 6 pieces of butter and a bag of sugar is 3.8 pounds. All right, so I'm going to draw a tape to represent the butter, and I'm going to add on to represent the sugar, and I'm going to show that that entire length is 3.8 pounds. All right. Now over here it says if the weight of the bag of sugar is 1.4, so I'm going to put butter and sugar, and we were just told that the sugar is 1.4 pounds. Now it says what is the weight of each piece of butter. So the first thing we need to do is we need to figure out how much butter is there. So that's going to be 3.8 subtract 1.4. That gives us 2.4 pounds. And so now that we have 2.4 pounds, this butter is going to be cut into 6 pieces. Why did I cut it into 6 pieces? Because it's got, it says so. We have 6 pieces of butter. So this whole thing is 2.4. And we're going to use division, and I don't like the fact that it kind of shows up there. So we're going to use division to show this one piece. What is that one piece worth? And so that's 2.4 divided by 6, and I'm going to let you finish that division. And that wraps up 5th grade Module 1, Lesson 14, dividing decimals, using that place value chart in order to understand this standard algorithm.